Hi, and welcome to Mr. Hamilton's Math Bites. This video is about families of parabolas, part 1. Now, the goals for today involve identifying the characteristics of each of the three families of parabolas, and then we're going to have a few other goals. This first video is going to deal specifically with this. The next part will deal with the second, third, and fourth goals. Alright, a family of parabolas is a group of parabolas that all share a common characteristic. There are three families we're going to look at, and you'll probably notice that each one of these families is representative of a different type of way of writing a quadratic. And that is first the vertex form, secondly the factored form, and thirdly the standard form, or otherwise known as the expanded form. Now, the first family that we're going to look at here deals with the vertex form, but that is in the case where h and k, the vertex, are fixed. H and k are fixed. What's varied is the a value. If we vary the a value and the h and k value are fixed, what we find is that all the family has the same vertex and the same axis of symmetry. The axis of symmetry, if you recall, is the vertical line that goes through the vertex. It's always in the form x equals some value, some number. We come to the factored family, and that is the case where we have s and r fixed. If s and r are fixed, and again, if the a value is varied, what we're going to find is that they have the same zeros, but the direction of opening may be varied and the vertex value may be varied, but they do have the same zeros. And you could also note that they would also have the same axis of symmetry. For the same reason as before, we know the midpoint between the two zeros has to be the axis of symmetry. In the third case, we have a standard or expanded form, and in this case, we would say that the value of c is fixed, and the values of a and b are varied. The only characteristic that this family shares is that they have the same y-intercept. Now, looking at this first family, that was where they had the same vertex. We're going to see four functions and see how those compare. Unfortunately, when I type a function into most programs, it always expands it for me. So you can see this is not actually in vertex form. So you could go ahead and you could complete the square to get that in vertex form, and notice that they all have the same vertex. But if I click on that or another one, this would also have the same vertex h and k value, or another one, you can see that there are variations that we can have of the parabola. They can look very different, but the key is that they all share that same vertex right there. That point is the same in that first family. Let's look at the second family. The second family that we have is the family that has the same X-intercepts, or the same zeros. In this case, -2 and 5. So if you were to go ahead again and factor these, what you would be able to see is that they all had the same r and the s values, and they would be -2 and +5. So in order for us to have values that are in this family, they all have to have the same r and s values. But again, they can vary in the vertical stretch. They can vary in where their vertex is, although the x value of the vertex will still be the same. But the y value of the vertex is going to change. And the third family is the family that shares the same y-intercept. And here you can see this function has a y-intercept of -2. And the nice thing about the expanded form is you can see the y-intercept directly from that. So you can clearly see all these are going to have the same y-intercept. Again, there's quite a variation what you can do with that same y-intercept. You can do a different vertex, you can have a different stretch or compression value, and you can change what that parabola is going to look like, whether it opens up or down as well. So there you have it, the three families of parabolas.